Good day to you. Howdy. In this class today, we want to look at redox reaction. As you have it here, what does redox reaction mean? This is one of the reaction that takes place in chemistry reactions. In the type of reaction that we have, such as combination reaction, decomposition reaction, catalytic reaction, thermal decomposition, to mention a few. We also have oxidation and reduction reaction. This oxidation and reduction reaction is the one we refer to as redox reaction. What is oxidation and reduction? We have different definition for oxidation and reduction. I want you to take note of this, very important, that this type of reaction, they are opposite forms of reaction but complement one another. For instance, oxidation can be defined as the addition of oxygen, while reduction will be defined as removal of oxygen. You can see that there's addition of oxygen, and the other one, which is reduction, is removal of oxygen. The two reactions are opposite one another, but they also complement one another. In other words, there is no reaction that occur with one of those reactions not being together. The two reactions are always coming together in the chemical reaction. You will see the reaction there. When you check it very well, you will know that this reaction is our oxidation or redox reaction. Now, let's look at different definition of redox reaction. Number one definition there is oxidation can be defined as addition of oxygen, while reduction, which is going to be the opposite of that definition, will be removal of oxygen. Also, number two, oxidation is defined as the addition of electronegative element, and also reduction is defined as removal of electronegative element. I want to simplify this for you. Now, you can see that you agree with me that oxygen is a form of atom with this oxidation number on it, O2 minus. If oxygen occur in its compound state, the oxidation number of oxygen will be negative. That is the oxidation number of oxygen, and it occur in a compound state. If it's not in peroxide, take note of that. Now, oxygen occur like this. I said oxidation is defined as, that's number one I gave you, addition of oxygen, and I also say that oxidation can as well be defined as addition of electronegative element. Take note of that. You can just use that one as a clip in order for you to be able to give a very good definition or detailed definition of oxidation and reduction. Why opposite of it? Reduction can be defined as removal of electronegative element. Oxidation as well is also defined as a removal of hydrogen, while reduction will be defined as addition of hydrogen. Oxidation as well can be defined as removal of electropositive element, while reduction too can be defined as addition of electropositive element. I want to give you a clue on that as well. You know that in a compound state, this is the oxidation number of hydrogen. Hydrogen ion will look like this. This is hydrogen ion, like this is oxygen ion as well. Definitely here, the oxidation number of this hydrogen here is +1. Now, oxidation can as well be defined as the loss of electron. The loss of electron, while reduction is defined as the gain of electron. This is a set of definition we can give to oxidation and reduction. I'm going to now look at them one after the other. In this class, I'm going to look at the addition of oxygen. We're going to focus on the addition of oxygen in this class, where I'm going to give you some few examples that can give us a clue how to identify which particular compound or which particular forms of a compound is oxidized and which one is reduced. Then we will also be able to identify what particular compound is going to be the oxidizing agent, and the one is going to be the reducing agent. So let's take a look at. Now let's look at few examples as regard the addition of oxygen, which means the oxidation reaction, and the removal of oxygen, how it occurs in chemical reaction. So let's look at the reaction between magnesium and oxygen. We have this. This is magnesium reacting with oxygen. We are going to have this as the product of the reactions here. You should agree with me that this is the reactant side and this is the product side of this reaction that we have here now. Now, you can see that this equation is yet to be balanced because we have two oxygen here, there is one oxygen here. So you need to balance the equation. If you put 2 here and you put 2 here, oh, the equation is balanced right now. So we can go ahead to simplify this now. You can see that looking at this reaction now, you agree with me that there is oxygen here. This is ordinary magnesium. Now, this one gives us a product of magnesium oxide. Now, from here, there's no oxygen in this one before, but down here, it has been able to achieve the addition of oxygen to itself. As oxygen has been added to this magnesium, so we can now call it oxidation reaction. Now, looking at this oxygen as well, there's oxygen here, but it has been taken away to this magnesium side. We call this one the reduction reaction. Now, having identified the oxidation line and the reduction line, we also need to know which particular compound or which particular atom is oxidizing agent and which one is reducing agent. Now, you agree with me that this is going to be our reducing agent, and this is our oxidizing agent. In other words, you can define reducing agent as that particular substance that absorbs oxygen towards itself, and you can identify oxidizing agent as that particular substance that give out the oxygen. We are going to also see some reactions here where we are going to be able to identify this reaction process very well. So I have other forms of reaction here where we have the carbon reacting with zinc oxide. Carbon plus zinc oxide. This is the reactant side. Going to the product side, we are going to have the reaction to become carbon plus zinc oxide will give us carbon 4 oxide plus zinc, CO2 plus zinc. This is the reaction because this is the reaction between the oxide of metal and that of carbon. Now, you agree with me that there's no this carbon here. From this reactant side here, there's no oxygen here. But when we get here, this carbon has been able to align oxygen or gain oxygen to itself. Adding up the others, now what? We now have what? Addition of oxygen there. So we call that one oxidation reaction. This is oxidation. And you can see that there is zinc here. This is the zinc oxide. And when this zinc gets here, it has lost, that is what? Removal. It has lost the oxygen that is with it at this reactant side here. This is a reduction process now. Reduction. In that regard, we can now call this. You also take note that where the oxidation emanates or emerge from the reactant side is what is going to be referred to as the reducing agent, and where the reduction emerge or come out from the reactant side will be the oxidizing agent. This is the reducing agent now, and this is the oxidizing agent. Reducing agent and the oxidizing agent. Let's look at another reaction here now. That is, reducing agent is the one that oxygen has been removed from, as I told you earlier. Now let's look at another reaction between iron oxide. That is, this is going to be, this is iron iron 3 oxide with you can see this reaction now. This is iron 3 oxide with carbon dioxide. Carbon dioxide. So which is going to give us when we have iron oxide, then it will give us now here we can see that here what we have here is 3 oxygen. But what getting here, the oxygen has been reduced to just 1. What we have here is 1 oxygen. Getting here, oxygen has increased to 2 oxygen. So, which one gain more oxygen? This particular one has been able to gain more oxygen when it gets to this side. So, this is going to be our oxidation process, and this will be our reduction process. And this is going to be our oxidizing agent, and this is going to be our reducing agent as well. That is how you can identify. You can see the way I do the analysis. You can see how I show you what happened on the reactant side and what happened on the product side. When you get to the product side, you look at that particular compound that has been able to absorb oxygen to itself. Then look at the one where it's coming from. Does it have oxygen? So getting there, you see that the one that absorbs oxygen to itself is going to be referred to as a oxidation process, and the one that give out the oxygen or removal of oxygen is going to be the one that will that oxygen has been removed from. We call it the reduction process. So taking a look at this very well, you see that these two compounds we have here, both of them are having oxygen, but there's one oxygen here. At this product level here, the oxygen of this ion here, this is iron 2 oxide, from iron 3 oxide to iron 2 oxide. You can see that the oxygen has been removed to just 1 oxygen here, whereas here the oxygen here is 3. When we get here, this one is, which is carbon dioxide before, has gone to carbon 4 oxide. So thanks for taking part of this class. We implore you to subscribe to our channel, keep watching our channel, and keep learning on a daily basis. Your exam is a sure success.